Hi students, good morning to all. Today same unit, chapter number 11, conic section. Last class we see about parabola and ellipse. Already exercise number 11.1 and exercise number 11.2 are completed. Okay, and 11.3 also completed. Next fourth one, exercise number 11.4. Fourth one, exercise number 11.4. Conic section, one type of conic section, hyperbola. Hyperbola is one of conic section. When beta value is 0 less than or equal to beta is less than alpha. Beta value is beta limit 0 less than or equal to beta is less than alpha, then the given conic section is a hyperbola. Okay, right. Definition of hyperbola. Definition. Define. A hyperbola is a set of all the points in the plane. A hyperbola is the set of all points in a plane, the difference of whose distance from two fixed points. The difference of whose distance from two fixed points in the plane is a constant. Listen. X-axis, Y-axis. This is hyperbola. Center at origin. Center at origin 0, 0. This is vertices A. This is called A dash or B. A is A, 0 and A dash is minus A, 0. Here X is a transfer axis. X is a transfer axis. F1 is one of 4 key and F2 is another one 4 key. F2. F1, M2 is 4 key. This is two fixed point. This is two fixed point. By the definition, set of all points in a plane. Set of all points in a plane. Let us consider P1, P2 and P3 or any points on this plane. Okay, right. Distance between P1 to F1 and P1 to F2. P1 to F2. Difference between difference of whose distance from F1P is difference F2P. F1P is difference, F2P is also equal to F2P2 difference P2 F2. Difference P2 F2. And also same value F2 P3, F2 P3, difference between F2 P3 and F1 P3. F1 P3. These are all same. That means F1 P1 is difference F2 P1 is equal to F1 P2. F1 P2 is difference F2 P2 is also equal to F1 P3 is difference F2 P3. This is a definition of a hyperbola. Listen. A hyperbola is a set of all points in the plane. A hyperbola is a set of all points in the plane. That is P1, P2, P3 and so on etc. P any points on this place. Let us take P1, P2, P3 and so on etc. Any points on this plane on the hyperbola. Okay, right. The difference of whose distance from two fixed points. Difference of the distance whose two fixed point. Here F1 is one fixed point and F2 is another one fixed point. Two fixed point whose difference between the distance from the whose That means the distance between P1 to F1 and P1 to F2, that is F1P is difference F2 P1. F1 P1 is difference F2 P1 is equal to P1 is any one point and P2 is another one point in this curve. Okay, so F2 P2 and F1 P2. So difference between F1 P2 and F2 P2 and difference between F1 P3 and F2 P3 also same. Okay, that is hyperbola definition. Hyperbola definition. This value is one constant. This value is a constant. And the constant value is 2a. Constant value is 2a. That is some distance between the transfer axis. That is length of the transfer axis. Length of the transfer axis. That means a dash value. 2a is mean a dash value. Listen. Here F1 and F2 is 2 foci. F1 F2 is foci. And what is the center? What is the center? That is midpoint of F1 F2. Center 0, 0 is midpoint of F1 and F2. The line joining the points F1 F2, that's midpoint is center. Okay, the center is called midpoint of the line joining F1 F2. Center is called midpoint of F1 F2. This line F1 F2 midpoint is O. This point is called center. Okay, next second, and the line joining the points F1 F2, this line is transfer axis. This line X is a transfer axis. Transverse axis. Here transfer axis X axis. Is X axis. This transfer X axis passes through F1 and F2 and center. This transfer axis X axis passes through F1, center at origin 0, 0 and the point F2. F1 and F2 are two fixed points. Okay, and conjugate axis. Here conjugate axis is y axis. Conjugate axis is y axis. Conjugate axis means the line segment whose perpendicular to the transfer axis, and this line is passes through the center 0, 0. This is called conjugate axis. Here x axis transfer axis, this is transfer axis, and this y axis is conjugate axis. Conjugate axis. Okay, right. Here A and A dash is vertices of a hyperbola. A and A dash are vertices of a hyperbola. That means this hyperbola, this curve, intersection of this curve and major axis, that is major axis means transfer axis. Intersection of transfer axis and the given curve hyperbola is A and A dash is called vertices. A and A dash is called vertices. Here A and A dash or vertices of a given hyperbola. Vertices, and F1 F2 is F1 and F2 or foci of given hyperbola. And the fixed line, two fixed line, this is x equal to a by e and x equal to minus a by e. X equal a by e and x equal to minus a by e, that is x equal to plus or minus a by e. These two fixed line is called directrix of given hyperbola. Directrix of given hyperbola. That means the equation of the directrix of given hyperbola is x equal to a by e and x equal to minus a by e. That is x equal to plus or minus a by e. X equal to plus or minus a by e. Here x equal to plus or minus a by e is fixed line. Fixed line. This line is called directrixes. This line is called directrixes. And chord of a hyperbola, this line is passes through foci F1, and this line so perpendicular to this major axis x-axis. This line is latus rectum. Latus rectum. This is x equal to AE, and another one latus rectum is passes through foci. This is latus rectum. Latus rectum. Okay. So the latus rectum is x equal to plus or minus AE. This is equation of latus rectum. Equation of latus rectum. Okay. Listen, hyperbola definition is F1P1 is difference F2P1 is equal to F1P2 is difference F2P2 is equal to F1P3 is difference F2P3. Here difference mean distance between F1 P1 and F2 P1. The minus here further distance minus closer distance. Okay, the difference mean further distance minus closer. That mean biggest value minus smallest value. Biggest value minus smallest value. Here difference mean positive value. Length of here this constant value is length of major axis is equal to length of major axis. So you know the length is called only positive value. They denote only positive value. So the further distance minus closer distance is positive value. So biggest value minus smallest value, we have only positive value. That means F1P1 is difference F2P1, and F1P2 difference F2P2, and F1P3 difference F2P3 is also same constant. That constant is positive value. The constant is positive value. So difference means biggest value minus smallest value. Here listen, here F1P1 and F2P2. This is F1P1. This line is F1P1 and F2P1. This line is F2P1. See here, F2P1 is longest distance, that is furthest distance, and F1P1 is smallest, that is closest distance. So difference between F1P1 and F2P1 is called F2P1. Here F2P1 is greatest value. F2P1 is longest distance. So F2P1 minus F1P1 is smallest distance. So F2P1 minus F1P1. This value is one constant. That constant is positive value. That constant is positive value. Here F1P2 and another one F1P2 difference F2P2. Here F1P2 P2 F1. F1P2 is the longest distance and F2P2 is closest distance. So F1P2 difference F2P2 is main F2P2 minus F2P2. F1P2 minus F2P2. And third one F1P3. So F1P3 value is greatest value and F2P3 is smallest. So F1P3 minus F2P3, we have some constants. That constant value is only positive. So the definition of hyperbola is set of all points in the plane whose difference between two fixed points. But that means F1, F2 is constant. That constant is positive value. This is the definition of hyperbola. Okay, here x-axis, this diagram, x-axis transverse axis and y-axis conjugate axis. Here origin 0, 0 is center. This center is midpoint of F1, F2 and A dash are vertices. These vertices are intersection of the transverse axis and this curve. That is called A, and A dash is vertices. And x equal a by e and x equal minus, that is x equal to plus or minus a by e. These are two fixed lines. These two fixed lines is called directrixes. And x equal ae and x equal minus ae. This line is passes through foci F1 and F2, and also these two lines are perpendicular to transverse axis. So the two lines x equal ae and x equal minus ae, that is x equal plus or minus ae is equation of lattice rectum. Equation of lattice rectum. Okay, right. Listen. X-axis, Y-axis, center at origin 0, 0. This is hyperbola A and A dash. A and A dash is vertices. F1 and F2 are for key. F2. Okay, right. Listen. This is hyperbola. Here transfer x-axis and conjugate axis y-axis. Okay, right. The center at origin and A dash are vertices of given hyperbola. Note. Here this point A is A comma 0. That means the distance between O to A. Distance between O to A. That means distance between center and vertex one of vertices A. CA. That means CA or OA. Note OA is equal to A. This distance is A. And also same value in OA dash equal to OA dash. OA dash value is also distance A. Here A dash is minus A comma 0. Here A dash is left of y-axis. So x value negative. That means minus A comma 0. So O to A value is A and O to A dash value is A. Okay, right. That is A dash. The distance between A dash is equal to 2A. A dash is equal to 2A. That is a length of the transfer axis. This is the length of the transfer axis. So length of the transfer axis is 2A. Length of the transfer axis is 2A. That means A to A dash. Distance between the point A to A dash is equal to 2A. Okay. So you know distance formula, root of A minus of minus, that means A plus A the whole square plus 0 minus 0 the whole square. Root of 2A the whole square is equal to 2A. That is 2A. So A dash equal to A. This value is the length of transfer axis. Length of transfer axis. Right. Next, second one. The length of conjugate axis. Is B dash equal to 2B. B dash equal to 2B. Here B dash. B dash. Draw the asymptotes of given hyperbola. This line is asymptotes. Draw a line from the perpendicular to the transfer axis. This is perpendicular line, and another one line perpendicular to and conjugate axis. This point is B. This point is B. Is perpendicular to the transfer axis and perpendicular to conjugate axis. This point is called B dash. So therefore, the length of a conjugate axis, that means B dash, the length of the conjugate axis B dash. This value is B, and also distance between O to B is B and O to B dash is also B. Therefore, B dash equal to B. So OB is equal to B, small b, and OB dash is also same, small b. So the length of the conjugate axis B dash is equal to 2B. Okay, listen. First point, the length of the transfer axis, that is A dash. A A dash value is 2A, and the length of the conjugate axis B dash is equal to 2B. B dash is equal to 2B. Here F1 is called AE, 0 or C, 0. So point F1 is AE, 0 or C, 0, and F2 is minus C, 0. Minus C, 0. Okay, right. Next, by the definition, F1P is difference F2P is equal to 2E. F1P is difference F2P. P is any point on this curve. P is any point on this curve. P is x comma y, and F1 is AC, 0, and F2 is minus C, 0. P is any point on this plane or this curve is equal to some constant. That constant value is length of the major axis, is equal to length of the major axis. So F1P is difference F2P mean further distance minus closest distance. Okay, right. Here let us consider PH. PH, A and A dash. A and A dash. First of all, any point on this P at A. So let us consider by the definition F1A difference F2A dash. Sorry, F2A. F1A a difference F2A is equal to, and another one point is A dash. P is at A and A dash. P is at A, then F1A difference F2A is equal to, second one point is A dash, then F2A dash. F1A dash is difference F2A dash is some constant. So by the definition, two values are same value. Okay, right. So F1A difference F2A. F1A is difference. See, right. This is center O. A and A dash are vertices. Let us consider PH, A and A dash. So F1, F2 are two fixed points. First of all, P at A. So let us consider A is any point on this curve. So F1A and F2A. Difference between F1A and F2A is equal to some constant. Okay, that constant is equal to 2A. That is the length of the transverse axis. Length of the transverse axis. Okay, right. Here F1A and F2A. Which distance is greatest? Here F2A is greatest value and F1A is smallest value. So the difference mean furthest distance minus closest distance. Here furthest distance is F2A. This is longest one, and F1 is smallest value. So F1A difference F2A is called F2A minus F1A. F2A minus F1A is equal to, and F1A dash is difference F2A dash. Here F1A dash is a furthest distance. This is a longest one. F1A dash, and F2A dash is a smallest one. So F1A dash difference F2A dash is equal to F2A dash minus F1A dash minus F1A dash. Okay, right. Substitute this value. F2A is equal to F2A. The value is, this is equation number 1. F2A is equal to F2O plus OA plus OA. F2O value is, this is F2O. So distance between center to foci is AE. let us consider we convenient A is called C. So this distance is C. O to F2 value is C. So C plus OA value, a distance between center to anyone that is a semi-transverse. Length of the semi-transverse is A. So OA is equal to A. So F2A value is equal to C plus A. C plus A. And F1A is equal to OF1 minus OE. F1A is called OF1. Let's take full length O2 F1 minus OE is equal to F1A. So F1A is equal to OF1 minus OE. OF1 minus OA. Here OF1 value is C. So distance between center to one of four key is C. And OA value is A. So C minus E. C minus E. Okay. So F2A minus F1A is equal to C plus A minus of C minus E. Minus of C minus A is equal to C plus A minus of C minus A. C and minus C plus A minus of C minus A is minus C plus A is equal to C minus C cancel, remaining 2A. This is left hand side. Left hand side of equation number 1. So F2A minus F1A value is 2A. Also same, F2A dash minus F1A dash is also similar, same value. So similarly we can F2A dash minus F1A dash is also same 2A. Therefore F1A difference F2A is equal to 2A. Is equal to 2A. Therefore F1AP is difference to F2P is equal to 2A P at A or P at A dash. Then the value is 2A. This is a truth value, two results. Okay, very important result. So F1P is difference, F2P is equal to 2A. 2A is length of the transverse axis. Okay, right. Right. Eccentricity of hyperbola. Is E equal to C by A. A equal to C by A. We know that and B squared equal to C squared minus A squared. B squared equal to C squared minus A squared. And B is equal to root of C squared minus A squared. Root of C squared minus A squared. So E is equal to C divided by C value. Substitute the C value, which implies C squared is equal to A squared plus B squared. But Alice has A squared equal to B squared plus C squared. A squared is equal to B squared plus C squared is Alice. Okay, but here hyperbola value C squared equal to A squared plus B squared. C squared equal to A squared plus B squared. So substitute this value. C is root of A squared plus B squared. Root of A squared plus B squared divided by A, which implies root of A squared plus B squared divided by A squared whole root of is equal to, so eccentricity is root of A squared plus B squared by A squared or root of 1 plus B squared by A squared. Therefore the eccentricity of hyperbola value is E equals C by A when C is equal to, here C is equal to root of A squared plus B squared, and the eccentricity value is greater than 1. Okay, here eccentricity is greater than 1. When the value of eccentricity of the hyperbola is greater than 1, then the given conic section is a hyperbola. Okay, so eccentricity values is greater than 1. Right. A standard equation of hyperbola. Standard equation of hyperbola. Two types of hyperbola. Here first one, type 1, x squared by a squared minus y squared by b squared is equal to 1. X squared by a squared minus y squared by b squared is equal to 1. Here transverse axis is x-axis, and conjugate axis, here positive terms, so x squared by a squared is positive, so the transverse axis x-axis, and negative terms minus y squared by b squared. Coefficient of y squared is negative, minus 1 by b squared, therefore the conjugate axis is y-axis. Okay, here x-axis transverse axis and y-axis conjugate axis. Let's say x-axis, y-axis, this is hyperbola. Here x-axis transverse axis was the center 0, 0, and A and A dash are vertices a, 0 and minus a, 0, and F1 is C, 0, that is AE, 0. Here C value is AE. So F2 is minus C, 0. Minus C, 0. Here center of hyperbola is 0, 0, and vertices A and A dash is plus or minus a, 0. Here A is a plus a, 0, and A dash is minus a, 0. And foci, two fixed point, that is F1 and F2 are two foci. Here plus or minus a, 0, or A is called, be convenient, A is equal to C, therefore plus or minus C, 0. Plus or minus C, 0. That is F1 is C, 0, and F2 is minus C, 0. F1 is C, 0, and F2 is minus C, 0. And equation of directrix. Equation of, that is directrix mean fixed point. Equation of directrix is x is equal to plus or minus a by e. This is equation of directrix. X equal to a by e and x equal to minus a by e. So x equal to plus or minus b. And equation of lattice rectum is x equal to plus or minus ae. So lattice rectum is passes through foci. This is plus ae and minus ae. So this line is cut at x equal to ae. This line is cut at x equal to minus ae. Therefore the equation of lattice rectum is x equal to plus or minus ae. Plus or minus ae. Okay, right. Listen, this is type 1. X squared by a squared minus y squared by b squared is equal to 1. Here transverse axis is x axis and conjugate axis y axis was the center. Vertices of a given hyperbola is plus or minus a, 0, and foci is plus or minus c, 0, and equation of directrix is x equal plus or minus a by e, and equation of lattice is x equal plus or minus ae. Same ellipse equation, first type 1 and major axis x axis same value but one different, and here x squared minus a by a squared minus y squared by b squared equal to 1. But the ellipse equation is x squared by a squared plus y squared by b squared equal to 1. Listen, hyperbola equation have coefficient of y squared value is minus. Here x squared by a squared minus y squared by b squared equal to 1. But the ellipse equation has x squared by a squared plus y squared by b squared equal to 1. And curve is different, but center, vertices, foci, and equation of directrix and equation of lattice is same. Both are same in type 1. And also eccentricity values root of, that is c by a. C by a is equal to root of 1 plus b squared by a squared or root of a squared plus b squared by a squared. This is eccentricity of hyperbola value. Eccentricity of hyperbola value is a squared plus b squared by a squared. That is 1 plus b squared by a squared. But the eccentricity of ellipse is 1 minus root of 1 minus b squared by a squared. Okay, right. Next, type 1, type 2 hyperbola. Type 2, y squared by a squared minus x squared by b squared. Here, coefficient of y squared is positive and coefficient of x squared is negative. Therefore, the transfer axis y-axis, and conjugate axis x-axis curve. This is a hyperbola. Here x-axis conjugate axis and y-axis transfer axis. This is a dash, center 0, 0, foci f1 0, c and f2 0, minus c. A is 0, plus a and a dash is 0, minus a. Here a fixed line directrix is y equal to a by e and y equal to minus a by e. The equation of a lattice rectum is passes through f1 is y equal to ae and y equal to minus a, that is y equal to plus or minus ae. Listen, center is 0, 0 and vertices is 0, plus or minus a. 0, plus or minus a. This is second order type. That is a is 0, a and a dash is 0, minus a. When the transfer axis y-x axis, vertices is plus or minus a, 0. But here transfer axis y-axis, the equation of hyperbola is y squared by a squared minus x squared by b squared equal to 1. Okay. Then the vertices of hyperbola is 0, plus or minus a and a is 0, a dash is 0, minus a. And same foci is 0, plus or minus 0, plus or minus a. Here 0, plus c, 0, minus a. That is 0, plus or minus c. So f1 is 0, c and f2 is 0, minus c. F2 is 0, minus c. So the equation of directrix is y equal to plus or minus a by a and the equation of lattice rectum is y equal to plus or minus ae. Same, eccentricity is same. So c by a or root of 1 plus b squared by a squared. This is type 2 hyperbola. Type 1 is transfer axis x-axis and conjugate axis y-axis. Type 2 transfer axis has y-axis and conjugate axis x-axis. Here the equation of hyperbola is y squared by a squared minus x squared by b squared equal to 1. Center, vertices, foci and equation of directrix, equation of lattice rectum and eccentricity. Okay, only 2 types. So ellipse has 2 types, major axis x-axis, minor axis y-axis, and second one type major axis y-axis, minor axis x-axis. Same as hyperbola has 2 types of hyperbola. Y squared minus a squared minus x squared by b squared equal 1 is transfer axis y-axis. And type 1 x squared by a squared minus y squared by b squared equal 1 and transfer axis x-axis. Okay, so only 2 types. Right. Next, derive the equation of a hyperbola. Let us consider transfer axis x-axis and conjugate axis y-axis. The equation of hyperbola is x squared by a squared minus y squared by b squared is equal to 1. Okay, first type equation. Right. F1 is foci and F2 and F2 are foci. F1 is c, 0 and F2 is minus c, 0. Minus c, 0. Okay. Center is O center 0, 0. A is a, 0 and a dash is minus a, 0. Okay, right. Let us consider any point on this plane P. P is any point. P is x, y. Okay. By the definition, the difference of the distance between F1P and F2P. F2P. By the definition, now find F1P and difference F2P. That is, here farthest distance is F2P minus closest distance is F1P is equal to constant. That constant is 2e. Is length of a major axis. We know that F2P minus F1P is equal to 2a. Right. Here F2P is distance between the point F2 and P. Here P is x comma y and F2 is minus c comma 0. So F2P is root of x minus, here first x2 minus x, x2 is x and x1 is c minus c. So minus of minus c is plus c. X plus c the whole square plus y minus 0 the whole square. Y minus 0 the whole square. Minus F1P. So distance between the point F1 to P. So x minus c the whole square plus y minus 0 the whole square equal to 2e. Equal to 2e. So simplify this. X plus c the whole square plus y square equal to 2a plus root of x minus c the whole square plus y square. Y minus 0 the whole square is y square. Take square on both sides. So x plus c the whole square plus y square is equal to 2a the whole square is 4a square plus a plus b whole square formula plus x minus root of x minus c the whole square plus y square is x minus c the whole square plus y square. Square and root cancel. Plus 2ab, 2 into 2a, 4a into root of x minus c the whole square plus y square. This is a plus b whole square formula. A square, 2a the whole square plus b square. This term squared and root is cancelled. Remain x minus c the whole square plus y square. This is b square. And 2ab, 2 into 2a, 4a into b, this answer. Okay? Right. So x plus c the whole square, x plus c the whole square is x square plus c square plus 2xc, a plus b whole square formula, plus y square, and here plus 4a square is minus 4a square, and plus x minus the whole square minus of x minus the whole square, that is x square minus c square minus 2xc is plus 2xc plus y square is changed into minus y square equal to 4a into root of x minus c the whole square plus y square. Okay, right. Here plus y square and minus y square cancel, plus c square and minus c square cancel, plus x square and minus x square cancel, remaining 2xc plus 2xc, 4xc minus 4a square, 4a square is equal to 4a into root of x minus c the whole square plus y square plus y square. So divided by 4a on both sides, divided by 4a on both sides, which implies 4xc divided by 4a is xc by a minus 4a squared by 4a is a, 4a squared divided by 4a is a, is equal 4a by 4 cancel, remaining root of x minus c the whole square plus y square. Take square on both sides, again square on both sides. So x by xc by a minus a the whole square is, that is x square c square by a square my plus a square minus 2 into a into xc by a, that is 2xc, a cancel, is equal to x minus c the whole square plus y square, x minus c the whole square plus y square. Simplify this. X squared c squared by a square, x squared c squared by a square plus a square minus 2xc minus 2xc is equal to x minus c the whole square is x square plus c square minus 2xc plus y square, minus 2xc minus 2xc cancel. Okay, right. So x squared c squared by a square So x squared c squared by a squared minus x squared. Here is x squared down, so change in left hand side, so minus x squared, and minus y squared plus y squared is changed right to left is minus y squared is equal to plus a squared, you convert minus s, so c squared minus a squared. Here also c squared is plus, here plus a squared converted minus a squared, so c squared minus a squared. Right, here x squared term is x squared of c squared by a squared minus 1 minus y squared is equal to c squared minus a squared. So x squared of c squared by a squared minus 1 is c squared minus a squared divided by a squared minus y squared is equal to c squared minus a squared. So divided by c squared minus a squared on both sides, they have c squared minus a squared is cancelled, x squared by a squared minus y squared by c squared minus a squared equal to 1, which implies here c squared minus a squared is b squared. So x squared by a squared minus y squared by b squared equal to 1, where b squared is equal to c squared minus a squared. B squared equal to c squared minus a squared. Therefore, x squared by a squared minus y squared by b squared is equal to 1 is equation of hyperbola when the Directrixes along x axis. Here b squared value is c squared minus a squared. C squared minus a squared. Here c is a. Okay. This is the derived equation of hyperbola. Therefore, the equation of hyperbola is x squared by a squared minus y squared by b squared equal to 1. Where b squared equal to c squared minus a squared. Similarly, we can prove type 2 hyperbola y squared by a squared minus x squared by a squared equal to 1. Same type. Okay. So, listen. Type 1 hyperbola Directrixes along x axis, then the equation of hyperbola is x squared by a squared minus y squared by b squared equal to 1. And type 2 Directrixes along y axis, then the equation of hyperbola is y squared by a squared minus x squared by b squared equal to 1. Only 2 types of hyperbola. Okay, right. Remaining latest rectum and exercise sums, see next class. Okay, bye. Okay.